Okay, so now I'm going to be going over using PhyML to create a tree. And the difference from MegaX, JavaView, and PhyML is that PhyML has an option for a web interface, so everything can be done online through the web, and you don't have to download anything. At least you don't have to download the program to create the tree. You might need to download some data to use for the tree, but the calculation stuff will be done on the server instead of on your computer. So use this URL and go to online programs. Once you open the URL, then where it says phylogenetics, go all the way down to where you see PhyML. And then this will be the submission page, and you just need to get some data, and then we can click the model. So in this case, before we get the data, you can click on, for the substitution model, we can use these methods, either of these methods, to automatically select the best substitution model for us. There's numerous substitution models, and we can use this method right here to give us the best one automatically instead of us individually selecting one. So click this, and then from there you can click on branch support and click on yes for a bootstrap, and I changed it to 50 in this example, and then provide the name, email, and your email. Confirm your email. After you submit the email, we can gather data. So to gather the data, we're going to be gathering ribosomal RNA sequences. So you can take this URL here and copy and paste it. After you copy and paste it, you can click on the hierarchy browser. Then for the search, we can just click on type and then leave everything the same and click browse. And here you'll get the domain, the bacteria, and we can click on a phylum. In this example, I'm going to click on Proteobacteria. And then from each session, I gathered sequences from different orders, different genus, and I collected some species too. I gathered 36 in this example. In this example, I gathered 37. And then from here, I click on the actual name, and then from here, I can click the symbols here to either unselect them or to select them. And if I want to look at the species within this genus, just click on the name, and then you'll get the species within this genus. Okay. You can click on download once you're done selecting the sequences you want. Just remember that from Proteobacteria, I collected from each class. From each class, I collected a few species from each class. So alpha bacteria, or alpha Proteobacteria, I collected some species here. Beta Proteobacteria, delta, epsilon, gamma, and that's it. And then once you want to download the file, download the sequences, click on download, change the download formats to phylip, and then click on download 36 sequences or X amount of sequences that you selected. You download it, and when you download it, it's going to be in phylip format. I already have one downloaded here. And then we can go to the PhyML, and we already selected the parameters. So we just need to input the file that we want to be used. And here's the sequences that I downloaded earlier. I can open it, and then you just click submit. If I was you, I would name it and then put your email and then click execute and email results. Once you get the results back, you should get a result in your email. I say to add your email because the calculations, the computation to create the tree might take a while. Once you get the results back in your email, you should get a link to the results page. And then you'll have the results page here, and then so remember what I said about the AIC, where it's going to give you the best model used. Instead of you having to determine what model to use, AIC will give you the best value, and it will choose models, give you a calculation. The lowest number here is the best model. So this model right here, GTR plus G plus I, has this value, which is lower compared to these values. So this right here would be the best model, as you see here. And we didn't need to do that ourselves. And if we were to do that in Mega, we might have to figure out what would be the best model in that case. Here we're using the AIC method to calculate what's going to be the best substitution model for us. Okay, and then we can actually visualize the tree. Just click on tree visualization, and you should get brought to this page here, and you can use different representations of the tree on whatever you deem is best to show the phylogeny, right? This one I'd probably just stick with linear, and you can see the distances, and you can also see the bootstrap methods. These are all pretty low bootstrap methods. 50, I mean, we can also increase we can look at each section if we want closer. 50, 50. Usually in the document I say about anything less than 50, 70% is not considered, would it be considered serious for a bootstrap value? Remember, the bootstrap value is giving you the reliability of these nodes. Right, the reliability, what's the accuracy? Here, 46%, 50%. If it was like 100%, that means like it's highly reliable, meaning when it's doing the replications, the bootstrap, when it's actually performing the bootstrap method, this particular node appeared in other trees 100% of the time, right? Lower the value, then it's not that reliable. Okay, but usually 70%, anything less than 70% is not going to be taken serious. Okay, so that's PhyML.